Hey guys, welcome to the lesson 30 problem set. So keep in mind that as I work through these, if you want to do them with me, this is just practice for you. Tomorrow when you come into class, that is when we will work together on the lesson 30 homework, and that is what I will be collecting. I am obviously at home with my girls tonight, so hopefully that doesn't cause too much of a distraction. So we're going to go ahead and try to move forward. Okay, so in today's lesson, we learned that we can divide by a decimal, and we can do that by creating a fraction and then simply getting rid of the decimals. And we do that by multiplying by a value of 10, depending on where our decimal is. So when we have 2 7/10 times 10, I would put that on my place value chart, and I would move it over one place, meaning I'd multiply it by 10, and my decimal goes to the end, which gives me just the whole number 27. And while the numerator is important, what we really want is a whole number here on this denominator. So since it was 3/10, I multiplied by 10, and now I just have 3. That gives me an improper fraction, and when I do the division, I get 9. On this one, you'll notice that there is a tenths place in the numerator, but the denominator is actually the hundredths place.
You need to do this fast.
The denominator actually is in the tenths hundredths place. So I would multiply, because I'm finding an equivalent fraction, whatever I do to the bottom, I have to do to the top. So when I do that, I get 3 on the bottom, but that 2.7, I've actually shifted that 2 rows on my place value chart, putting the 2 in the hundreds place, the 7 in the tens place, meaning I would have to fill that in with a 0 in the ones place. So when I do that, I can look at that and see 3 goes into 270. If I have 2 hundreds blocks, I can't make a group of 3. So I would take those 2 hundreds blocks and break them into 27 tens. If I took those and started pulling them and making groups of 3, I would be able to make 9 groups. When I make those 9 groups, I use all 27 of the tens blocks. But I don't have anything above this 0 yet, so I'll have to bring it down, and 3 goes into 0 times. So my answer here is 90. All right, let's look at letter C. The first thing that I'm going to do is I'm going to set this up as a fraction. And then I have to get rid of that decimal. So since we're working in a tenths place, I'd multiply the numerator and the denominator by 10, and that would give me 35 over 5, which makes my answer 7. Here we're working with the same numbers, but it's just like the one above. So I have a tenths place as the numerator, but my denominator is actually in the tenths hundredths place. So that means I have to multiply both the top and bottom by 100. When I do that, I get 350 over 5. Now, I could set this up in like a long division problem, but I could also look at it, and because this is a power of 10, I know that 5 goes into 35 7 times, and because it is a power of 10, I'm going to add a 0 there. Okay, so remember, the way I'm going from 3.5 to 350 is when I put it on that place value chart, like I did last night, and I move it over two place values. So that 2 that was in the ones place, or I'm sorry, that 3 that was in the ones place moves from the tens to the hundreds. So I'm just moving right across that place value chart. Here on letter E, I'm going to rewrite it as a fraction. I'm working, my denominator is in the tenths place, so I'm going to multiply by 10 to find my equivalent fraction. And that equals 42 over 7 equals 6, because 7 goes into 42 6 times. On this side, again, I'm going to set it up as a fraction. Now, this time it's not following the exact same pattern that we've been doing. My denominator does change to the hundredths like it does here, but my numerator is also in the hundredths. So I have to be careful here and put it on that place value sheet. Because I'm working with hundredths, I'm going to multiply the top and the bottom. When I put it on that place value sheet, if I move it 1 time, the 4 becomes a 1. If I move it 2 times for 100 times, that 4 becomes a 40.
Mommy, Gracie's like sucking on a stick. Should I give her suckers to suck on?
No. Sorry, friends. All right, so here I'm going to try to go a little bit quicker now. I have 10.8 over 9 tenths. Because my denominator's in the tenths, I'm going to multiply it by the tenths. That would give me 108 over 9. I'm going to set that up like a long division. 108 divided by 9. Can't do anything with that 1, but if I have 10, I can make one group of 9s, and I would use 9 blocks. Bring down that 8. 9 goes into 18 2 times. So my answer here is 12. My quotient is 12. Set it up. 1.08 divided by, that would give me, whoops, I'm going to multiply by tens, hundreds. When I do that, I get 108 over 9. So it's the same thing here as I had here. So I know that my quotient then is 12. I'm going to let you work these because these are very repetitive. I will just give you the answers. The answer for I is 3. The quotient for J is also 3. Sorry, let me zoom out there a little bit for you. The quotient for K is 7. And the quotient for L is also 7. So let's come down here to number 2. Here I have a division sentence. 15 divided by 3 equals 5. Explain why it is true that 1.5, 1 and 5 tenths, divided by 3 tenths, and 15 hundredths divided by 3 hundredths have the same quotients. All right, we get very tripped up on these word problems and trying to figure out what it is that we want to say. So I'm going to answer the question here. They have the same quotient because I can rewrite them in unit forms to show they are equal to 5. So there is my writing portion of this. Now I'm going to draw that so that my reader knows what I'm talking about. 15 divided by 3 equals 5. Check. Then I have 1.5, or 1 5/10 divided by 3/10. I would multiply both of those by 10, just like I've been doing. That becomes 15 over 3, which is 5. And then I have 15 hundredths over 3 hundredths. I would multiply both of them by 100. And again, I get 15 over 3, which equals 5. So now I have explained my thinking in in writing and with a drawing. Okay, number 3, with these names, these are so crazy. Mr. Volek buys 2 4/10 sugar for his bakery. All right, so that's the part that looks like I'm going to have 2 questions to answer about that 2 4/10 kilogram of sugar for his bakery. So if he pours 2/10 of a kilogram of sugar into separate bags, how many bags of sugar can he make? Zoom in there a little bit for you. All right. So for A, I have the 2.4 kilograms of sugar, and I'm going to divide that in the 2/10 of the sugar into separate bags. And I want to know how many bags of sugar can he make. So I can rewrite this as a fraction. And now this is exactly what I've been doing. So I know to multiply both of those by 10, I get 24 over 2. And I wind up with 12 bags of sugar. All right. So now, this is one of those domino problems. So we've got our first piece of the domino, it fell, and that helped us solve this piece. So now we're going to say if he pours 4/10 of kilograms of sugar into separate bags, how many bags can he make? So sometimes we have to use our answer here to solve the next problem, but in this case, we still have the 2.4 kilograms, but this time he's going to divide it by 4/10. So there I get 24 over 4, and that gives me 6 bags of sugar, which if you double check, that makes sense because here he's using twice as much, so that means that my answer should be half as much. All right, number 4 says 2 wires, one 17 4/10 meter long and one 7 5/10 meters long, were cut into pieces 3/10 of a meter long. How many such pieces can be made from both wires? Okay, so we've got 2 separate wires here. So we can take each one separately, or since I want to know both wires, I'm going to go ahead and I'm going to add these 2 decimals together. So I have 17 5/10, and I'm going to add that to 7 5/10. Now, anytime I am adding with decimals, it doesn't matter what's in front of the decimal or what's behind the decimal. I have to make sure that my actual decimal points are stacked up on top of each other. Okay? So you can always fill in with a 0 if you need to make your problem look more complete, but you've got to make sure that those decimals are stacked up on top of each other. And now I just add as usual, bringing my decimal down. Okay? 14, 15, okay, 25. So, cut into pieces 3/10 of a meter long. Oops, that's 300. I'm sorry. Let me start over. This is why we don't do math in ink pen. All right, so I've got 25 meters, and now I'm going to divide that by 3/10 of a meter. So again, I want to get rid of that decimal by finding an equivalent fraction. And I wind up with 250 over 3. So now I'm going to have to do some long division to solve this. If I have 2 hundredths blocks, I cannot make a group of 3. So I would go and I would bust up those hundredths blocks, and I would get some tens. And I would have 25 tens. If I start making groups of 3, I'm going to be able to get 8 groups of 3. When I do that, I'm going to use 24 of those blocks. Then I can subtract. I would have 1 10 left. I can't make a group, so I would go and I would break it into ones, and I would add the other ones to it that I have. So when I do that, I have 3 goes into 10 3 times. I would subtract. And I would have a product of 83 with a remainder of 1. Well, when I'm cutting things, I can't have a remainder. So that means I can make 83, and there will be a little bit left over, but not enough for a whole. So my quotient here would be 83. I'm going to circle it so that way I know. And finally, on the bottom, Mr. Smith has a 15 6/10 pounds of oranges to pack for shipment. He can ship 2 4/10 pounds of oranges in a large box and 1 2/10 pounds in a small box. If he ships 5 large boxes, what is the minimum number of small boxes required to ship the rest of the oranges? Okay, well, let's start by figuring out he can ship 2 4/10 pounds of oranges in 1 box. Well, he has 5 boxes. So let's figure out, I could do 2 4/10 plus 2 4/10 plus 2 4/10, or I can use repeated addition. 5 times 4 is 20. 5 times 2 is 10. So he'll be able to get rid of 12 pounds of oranges in the large boxes. So if he had 15 6/10, and he's going to be able to package 12 of them. So again, if you notice here, 12 is my whole number. So I can add a 0 here to make my problem look more complete. But that 12 goes under the 15 because that is my whole number. 6 take away 0 is 6. 5 take away 2 is 3. So he has 3 6/10 pounds left. Okay? So if he has 3 1/6 pounds left, and he can fit 1 2/10 in a small box, we're going to figure out how many small boxes he needs. So this is the same thing that we've been doing. It just takes several steps to get through it. The best way to attack these word problems is just to take it one little piece at a time, just like I did there. All right, you've got to figure out what you know and what you're trying to get to. It's part of the puzzle. All right, so then I'm left with 36 over 12, 12, 24, 36. He would need 3 small boxes. Okay, well, that concludes lesson 30 problem set. Remember, tomorrow, this is not what you will turn into me. I've done all this work here. So tomorrow, you need to make sure that you turn into me lesson 28 homework, lesson 29 homework, and lesson 30 homework. That is what is due by the end of our class time together tomorrow. Take the opportunity to go back through, watch the video, listen to the steps. A lot of you, I'm noticing, are going ahead and as you're working the homework, you're watching this video for the problem set, which that is some smart thinking. Because even if you don't understand it, just by practicing those steps, you are going to become an expert. It just takes practice. Okay? I don't know why when I kick a soccer ball with the tip of my toe, I have no control over it. But when I kick it with the inside of my foot, I can get it to where I want to go. But if my coach tells me you just keep kicking it with the inside of your foot, eventually I'm going to do that automatically. And that's what's going to happen with you as mathematicians. You keep practicing this, and when you see these problems, you're going to be like, oh yeah, my brain automatically knows what to do. So I'm looking forward to seeing how your exit tickets go tomorrow. Remember, when you come in, you're going to have a seat on the carpet, and we're going to go through our fluency to get us started. Have a great night, mathematicians. I'll see you tomorrow.